Alright, what are we doing today, Kyle?
We are repairing our swamp cooler.
What happened to it?
Well, I wasn't there, but Gabe says that about 9 o'clock at night, it woke up to a colossal crash, and one of these blades had vibrated and came off, and you can see what's left of it right there. Not much. So, I designed this. It's supposed to ideally fit onto this here. So here's the mounting plate. I designed this and then I printed it off individually because it would only take an hour instead of, you know, I don't know how long the big ones take, but it would take a long time. I made a construction plane out here, so that's the distance away from the axis, which is the length of the blade. And then I put the profile of the airfoil over here and another one down here. You can see they're at different angles to each other. And then you loft between them, which creates your gradual curve along the blade. And then I was just adjusting the angle to make it more true to the real one, and so that eventually the angle was the same on this side as it was on this side, so that we wouldn't have any issues with overhang printing. We do have to bolt it down, then we have to observe from a distance.
Well, you don't want to be super close when this thing goes off?
No, what do you mean goes off? It's gonna work perfectly. I'm just not gonna be near it when it works perfectly. Yeah, I am skeptical, but the layer lines are in the direction of force. I would have preferred to, you know, print it in that direction, but then you'd have an awful airfoil. And, you know, there's a bit of a washout there. But we'll see, I'm excited. I guess we'll show you guys too. Good morning, we're back the next week. We've got the final fan blade printed off and a spare. And yeah, it looks like today we're gonna turn it on and see if it works. Mine's a bit smaller, and the next version will probably try and make it bigger again. I think it'll work, yeah. I'll be standing away from it when we turn it on.
Yeah, no, we'll have to. I think we'll all be standing away from it pretty far.
We'll get the health and safety guy over.
What are we talking about?
Where we're gonna be when we turn it on.
You're gonna, oddly enough, be right to the side of that whole thing,
no.
so that housing protects humans.
Yeah.
But yeah, we can just mount up the screen on this all.
I'd really
Nice.
like to give photogrammetry a go at some point. I think this would be a good application for it.
Why?
To copy a part exactly. I think it'd be cool.
In all fairness, we don't want to copy the part exactly on these.
Yeah.
We shouldn't even be copying the part exactly on these as it is. Like these things with these propellers, if we did another version of these, do we have any microstructures in here?
No.
Cool. Microstructures are like putting in little pinholes inside of here so that it induces more walls. The things we could do with this is that whole part could be thickened up like an inch because we can, so that you actually have beef back behind there and basically round around that whole thing. And then
There's a little tab in here which this locks into to keep these facing that direction.
it's that tab, isn't it?
No, these parts here.
Oh.
So this is already a bit too thick. It's not really engaging it that well.
What's
Just
wrong with it?
this part. There's nothing wrong with it.
Oh, the rotation of that thing?
Yeah.
Ah, who cares?
Yeah.
It's there. Yeah. Yeah, the main thing we're gonna wonder about is the split out of that whole thing.
Yeah.
But I don't think it's gonna be that big of a deal. The one thing I am worried about is they're a little bit shorter. These whole ducted fans are ducted fans. Having that gap right there, we may lose the suction that we had on there because the air will just bounce around from out there and back around and all the rest of it. That's an overhyped thing because it's an AC swamp cooler. I'll bet it's not that precise.
It'll be fine.
I'll bet it'll be fine, but even so. The layer lines have to go that direction to keep it from flying apart because we certainly don't want to print it flat, but having these actually adhere more is just making it thicker. And actually making it thicker on this side would also help as well, just for the sake of having more adhesion on this side so that if it does crack, it can't just fly apart and propagate on down. I'll bet they'll run longer than we expect them to.
So you said the last one failed because water hit it or something?
So there was water going into the front and it hit one of the propellers, so they basically ran through a splash, and when stuff moves fast, water's kind of hard.
Yeah.
Did you mention these are PLA? This is your Tangled PLA. Really good stuff. The Tangled is great for large format 3D printing because since it's only $10 per kilogram, you get it for cheap. No, yeah, I don't think it'll turn, yeah. Get a screen on there on the front and we can turn it on and go slow and whatever, the twisty knob's over there, it's fine. It flew off already, I was fairly close to it when it happened, it's not that bad.
All right, go ahead.
Starting out on slow. It's going. All right, faster.
Yeah, take that fast.
More. It doesn't sound like it's speeding up. Send it, he steps back.
That revved up more. 3/4 couldn't fly. It's bad because everybody's gonna crank it up to full speed.
Yep.
Trying to get more air out of it.
I don't think people are gonna have it this high.
Yeah.
It works.
It does. It didn't blow up. No freaking way. Oh wait, we're family friendly at Slant 3D. We won't say that word.
So, when we redo any of these things, we can impregnate, we can cover it with Flex Seal, we can make the propellers longer, we can do all the things to make the propellers better. But this is 3D printing. We want to do a 3D printing thing. 45 inches. 400 is 13 inches, so we can do like technically a 36 inch. Oh no, we didn't do bigger than that. What's 400? What's 800 millimeters into inches?
26 mil per inch, I think.
Well, thanks.
So good luck.
I ain't mathing. We can make a propeller this big that's toroidal if anybody wants one. But then we also have to redo the hub and everything weird.
One of the bigger issues that's stopping it from being faster is probably that the twist isn't right.
And there's a big old gap around the outside. And it's
Yeah.
not going very fast.
Yeah.
It's a circle. We lost like a third of the airflow with that outer 3 inches.
It's true.
Comment if you think we should do a toroidal fan, the biggest one on the planet, because nobody else has done that yet. So it's still only 30 inches, which is not very much. Oh, you know what we could do though? We can. Oh no, we can make a giant toroidal fan. This video better get a bunch of views, and then we'll redo the hub and make a toroidal fan that's 4 feet wide.
You're gonna have to explain what a toroidal fan is to the people out there, and me.
Editor, throw in a photo of what a toroidal fan looks like. Everybody wants that. Perfect. This split, I can't make it split like consistently. I can feel it in, oh, it's not even split at the spot where it looks like it's split. You would think it was split right there, but it's not. It's split up above, which is wildly disconcerting when we're trying to evaluate where these things are gonna break. But how? That's how hard it takes to break it. Hold on. Stand clear. So that's what the inside looks like. Foamy. That's what infill looks like when you have a 1 millimeter bead. That is, I believe we used rectangular infill on that one, rectilinear. 3 walls. Boy, we should use this for demonstrations of how 3D printing works, because that's a really good infill appearance. You can see every layer line, it's really clear to everybody. Just cross sections of this makes everything so easy. But it didn't take much beating to break that. I can definitely break this, but I'm scared of cutting myself. Oh, well, that spot's already kind of started. Hang on.